Assalamu alaikum, this is Rafiq Ali Ahmed, and my topic is protein binding and its significance. Whenever a drug is going to be administered into the body, the drug molecules are going to be present in the gastrointestinal tract, and they are going to be absorbed along the gastrointestinal tract into the systemic circulation, where the drug may be present as a free form. Now, this drug can be bind to the proteins, otherwise it can undergo the metabolism. So, when it is going to be metabolized, at most of the times it is going to come to inactive metabolites. So, metabolism is one of the mechanism by which the reaction is going to be terminated, but at the same time the drug can also bind to these proteins. When the drug is going to bind to these proteins, the drug can form a complex with the protein. Now it is present in the bond form, and sometimes this complex can be dissociated such that it again released as a free form of the drug. In this way, within the systemic circulation, the drug is present as a free form or as a bond form. The free form is the active form of the drug, whereas the bond form is the inactive form of the drug. So protein binding is a reversible process where the drug is going to be converted and in inactive form on binding with the proteins, and it is reconnected to active form when it is going to be dissociated from the proteins. The therapeutic action of the drug mainly depends on the free form or the active form of the tract. That's why the protein binding are very important in order to assess the kinetics of the drug as well as its therapeutic action in the body. So drug molecules within the systemic circulation, they can bind to the protein molecule. Suppose the drug molecules are going to bind to this protein, and here you can observe you have the proteins are free and they are not bound with the drug. Now we can draw one of the kinetic equation for this protein drug interaction, uh, in which protein drug complex and this rate of dissociation can be given by the rate constant k. Similarly, the protein drug complex can be dissociated to again reconvert into a free drug as well as a protein. Now here the drug is available as a free form as well as, so here dt is the total drug concentration, and now what is this fraction indicates? This fraction indicates how much of the drug is available as a free form compared with the total conservation of the tract, and which is available to show its therapeutic action. And this fraction indicates the volume of distribution of the tract. If the drug is having the high concentration of the unbound form, then this fraction of the drug unbound is very high. Thereby the volume of the distribution is also very high. So higher volume of distribution indicates that the drug is not binding to the plasma proteins and it is going to be more distributed into the body. So extreme vascular distribution will be more when the drug is having the less binding with the proteins. In this way, this fraction of drug unbound indicates the volume of distribution, but it will not give the information about the kinetics of the protein binding. But here the volume of distribution depends on which type of protein is going to interact with the drug, because the drugs can bind to the proteins which are present in the plasma proteins, and this is the tissue having the different types of protein binding sites. Now the drugs can bind to these plasma proteins as well as they can also bind to the what are the proteins binding sites present on the tissues. When the drug is going to bind to the tissue proteins, it can result in the therapeutic actions, otherwise you can produce the adverse reactions.